In this video, we'll be comparing lamprey, dogfish, and this species of Actinopterygii. The fins of the lamprey only include anterior and posterior dorsal, as well as a caudal fin. The dogfish and the Actinopterygii both have pectoral, pelvic, anterior, and posterior dorsal, and tail fin. The Actinopterygii also has an anal fin. The greater number of fins on the dogfish and the Actinopterygii allow for greater mobility and control of pitch and yaw. In the dogfish, we find a heterocircle tail, in the Actinopterygii a homocircle tail, and in the lamprey a protocircle tail before the tail fins split into a more defined structure. In the dogfish, the heterocircle tail allows for much faster swimming, but unfortunately leads to bad stabilization and movement. The outer coating of the dogfish was heavy and very rough, while the outer covering of the Actinopterygii and the lamprey was overall very light and smooth, and the skin of the lamprey was soft rather than having scales like the dogfish and the Actinopterygii.
This slide compares the mouths of the lamprey, the Actinopterygii, and the dogfish. First off, in the upper right lies the lamprey's mouth. The circle surrounds an area called the buccal hood. Further in, at the very surface of the mouth, are small projections, which are referred to as buccal pupillae. Further in lie the epidermal teeth, which are often used for sectioning off pieces of flesh. And furthest in lies the buccal cavity, which leads into the digestive system. In the lower right lies the Actinopterygii. While it's not a clear picture of the inside of the mouth, the blue circle gives a general location of where the teeth would be located. Within posterior to the mouth lies the oral cavity, which is just an empty space, which will eventually lead into the digestive system. On the left lies the dogfish, in which the circle represents where the teeth are located. Noticeably, posterior to that circle lies the tongue, and even further down the rest of that digestive system, which will be covered in the next slide. As a continuation of the previous slide, this slide shows the esophagus and pharynx of both the lamprey and the dogfish shark. So notably, in the upper left is a circle for the lamprey, which shows where the location of the pharynx, which lies behind the oral cavity. Further behind that circle, it goes into the esophagus. Now in the lower right is the circle, again shows the pharynx of the dogfin shark. Further down is the esophagus, which is notable for its esophageal papillae that line its surface. Beyond the esophagus lies the stomach for both species. Similar structures exist within the Actinopterygii, however, we were unable to get a clear picture of them. This slide shows the differences in gill slits between the Actinopterygii, lamprey, and dogfin sharks. The upper right and upper left have red circles showing the general area of the gill slits. Notably, the upper right shows an internal view, while the lower left shows an external view. However, in regards to the dogfish shown in the lower right and the Actinopterygii shown in the upper left, they both have a yellow circle showing the general area of the gill rakers, which are used to filter out any debris that might clog the gills themselves. Behind them lies the gill arches, which connect them to the gill filaments. The filaments themselves are the site of oxygen exchange between the blood and the gills themselves. Notably, in the Actinopterygii, the gill rakers are more of a hard bone-like structure, while the while in the dogfish shark, they're closer to cartilaginous tentacle-like structure.
In the green circles are the livers of the actinopterygii on the left, the lamprey in the upper right, and the dogfish shark on the lower right. Comparatively, the liver of the dogfish is much larger, and it has actually 3 livers, 2 of which are shown. This larger fatty liver is used to weigh down the light cartilaginous skeleton of the dogfish and is part of its mobility. In the lower left is the swim bladder of the actinopterygian, which it uses in order to move up and down the water column. Because the actinopterygian doesn't require a fatty liver for this function, it is much smaller. The lamprey, on the other hand, has a small liver and does not have a swim bladder for moving up and down the water column.
This slide displays the myomeres of the apterygian, the dogfish shark, and the lamprey. In the upper right is the apterygian, which lies beneath its scales. In the lower right lies the lamprey. Noticeably, there are 2 yellow circles, both of which are myomeres, which surround it. These take approximately a third of its total width. Now, for the left picture, it shows the example in the dogfish. Unfortunately, there wasn't a clear picture of the myomeres, but they lie underneath the surface shown. As you can clearly see in both of the right pictures, the myomeres are clearly striated, and overall they function being that they are muscle cells for movement. In the upper 2 pictures, the dogfish and the apterygian, you can see that they're more closer to sheets, while they're a lot thicker in the lamprey. And with this, we conclude our dissection slideshow.